Let us look at proposition number 27 of book 6 of Euclid's Elements. The proposition says, of all the parallelograms applied to the same straight line falling short by parallelogrammic figures, similar and similarly situated to that described on the half of the straight line, that parallelogram is greatest which is applied to the half of the straight line and is similar to the difference. Okay, so we need to do a little bit of construction to break down that proposition. Parallelogram on half of AB. So let's take the midpoint, or let's bisect AB. Let's draw a line parallel to BE through C. So we have half and half of the parallelogram on AB. So the proposition is saying we have to draw a parallelogram which is similar to parallelogram DB. Now, how do we do that? We join DB and we take a point on that. And then we draw a line through F parallel to BE, and we draw a line parallel to AB through F. Yes. So let's do this one by one. So we have GH parallel to AB. Similarly, we draw a line through F parallel to B. So let's again draw that. So KP is parallel to B. Now, what the proposition is saying is that the parallelogram on the half of the parallelogrammic figure, which is on AB, that is AD, will always be greater than any parallelogrammic figure AF falling short by a similar and similarly situated parallelogrammic figure described on the half of the parallelogram on AB. Seems tricky, right? So basically what it is saying is that we have similar and similarly situated figure FB, yes, which is on CB. CB is half of the AB. So AF is a parallelogrammic figure which is falling short of the parallelogrammic figure on AB, falling short by FB, which is similar and similarly situated to DB. Basically, that's what it means. Now we have to prove that AD is always going to be greater than AF. So let's do that. We know parallelogram DB is similar to parallelogram FB. Why? Because they are about the same diameter. Okay. We also know parallelogram CF is equal to FE. Why? Because they are complementary parallelograms about the same diameter. Now let's add FB to both the sides of this equality. So parallelogram CF plus FB is equal to parallelogram FE plus parallelogram FB. Since we are adding the same thing to two equal things, they will be also, the result will also be equal. Now, parallelogram CF plus parallelogram FB is what? Parallelogram CH. And parallelogram FE plus FB is KE. So that means parallelogram CH is equal to parallelogram KE. Now, parallelogram CH is equal to parallelogram CG. Remember, C is at the midpoint. So CH is going to be equal to CG. Now, parallelogram CG is equal to parallelogram KE. CG is equal to KE. Why? Because here you have parallelogram KE equal to CH and CG equal to CH. That means KE is equal to CG. Now, to this equality, we add CF to both the sides. So, parallelogram CG plus CF is equal to KE plus CF. Now, CG plus CF would be AF and KE plus CF would be the gnomon element. Parallelogram DB is going to be greater than gnomon element. Yes, because DF is missing from this part. So, which means DB is going to be greater than gnomon element. But we know AD is equal to parallelogram DB, which means parallelogram AD is going to be greater than gnomon element. But gnomon element is equal to AF. Yes, parallelogram AF is equal to gnomon element. So, which means we can say parallelogram AD is greater than parallelogram AF. So, we have proved that parallelograms applied to the same straight line falling short by parallelogrammic figures similar and similarly situated to that described on half of the straight line. That parallelogram is greatest which is applied to the half of the straight line and is similar to the difference. That is proposition number 27 of book 6 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.